And we're back. This is properties of log functions. That's the lesson for today. We're going to simplify and evaluate expressions with logs, and we're going to solve equations with logs. Doesn't that sound exciting? I know you guys are beside yourselves. If m, n, and b are greater than 0, and b does not equal 1, then there are some things that we can conclude about exponents and logarithms. Now we got some rules, and now you guys might remember the product property. Okay, for exponents it goes like this. No, I'm going to make this colorful today, so I'm going to change colors every chance I get. So for exponents, and when I write this down, you're going to understand what I'm talking about. A to the m times a to the n equals a to the m plus n. You remember that? That is the product property. That's how that works. And then we had the quotient property. And the quotient property goes like this. It says a to the m over a to the n equals a to the m minus n. Now you've been doing this, you've been practicing these real well for a while now, so this shouldn't be anything new to you. If you're multiplying, if you have the same base and two different exponents, you're multiplying these two powers together, you just add the exponents. If you have the same base and you're dividing these powers, you subtract the lower exponent from the upper exponent. And once again, you know, we've been doing this for a while now, so this is no big deal. And then there's the power trip. No, just kidding. Power property. Okay? The power property is that thing that says a to the m raised to the n power equals a to the m times n power. You remember all those? Good, because we're going to show you how similar properties for logarithms. There's corresponding properties just like that. So for logarithms, remember a log is what? It's an exponent. Okay? So for logarithms, if you have log to the base b of m times n, that is equal to log to the base b of m plus log to the base b of n. You see, we just add the exponents. Remember, a logarithm is an exponent. So we're doing the same thing here we're doing over here. We're adding the exponents. So log base b of m times n equals log base b of m plus log base b of n. So, in the same thing here, the quotient property, log base b, sorry about that, of m over n equals log base b of m minus log base b of n. Now when it says equals, that means we can go both ways. If we start with the one on the right, we can end up with the one on the left. If we start with the one on the left, we can end up with the one on the right. And finally, the power property of logarithms goes like this. It's log base b of m to the p power. And this is where it gets interesting, because here's what I'm going to do. I'm going to take this p, and I'm going to multiply it by this. Now what we did here is we took this n and multiplied it by this exponent. We're going to take this p, which is an exponent on what we're trying to find the log of, and we're going to bring that around to the front and multiply it. So it's going to be p times log base b of n, or m rather. I'm sorry, that was an m. Better stick with my same thing. M. And okay, things aren't working the way I want them to tonight. But anyway, p times log, and I'm going to do an example each one of these, okay? And so to start with, we have to change to this different color now, okay? So I'm going to show you an example of the first thing, okay? And that's the product property. And suppose we have, if I give you this advanced information, I'm going to tell you that the log base 2 of 3 is equal to 1.5850. So this is background information which we're going to need in order to solve these problems. Okay, so start with this one. How do I find log base 2 of 12? Now you button pushers out there are going to look at this and you're going to say, well, I don't need to waste my time with this. But you know what? I'm the kind of teacher that would give you a quiz and tell you you cannot use your calculator. Okay? So do not assume that simply because you got a calculator you can push buttons on that you don't need to spend time learning this. Trust me, this is not a something that I'm going to let you slide on. So what this is equal to, remember 12 is equal to 4 times 3, which is equal to 2 times 2 times 3. Now why would I break it down like this? Well, first of all, log base 2 of 2 plus log base 2 of 2 plus log base 2 of 3. Because what I did now is I just did the reverse of the product property. Remember I said you can go back and forth with this. If you have log b of m times n, in this case we got 3 of them, then that's equal to log base b of m plus log base b of n, etc. So let's see what we have here. Log base 2 of 2 is 1. Log base 2 of 2 is 1. And log base 2 of 3 I have up here is 1.5850. Add those three together and what do you get? 3.5850. Okay? Let's try another example. This one says log base 2 of 1.5. So how can I use log base 2 of 3 to solve this? Well, 1.5 is 3 divided by 2, isn't it? So this is actually log base 2 of 3 divided by 2. 1.5 is equal to 3 halves. So why does that help me? Because now I can break this down into log base 2 of 3 minus log base 2 of 2. What's that equal? Well, 1.5850 minus 1 is 0.5850. Isn't that cool? So we can also do this as a single log. We can say, we can connect things and do it the reverse of what I told you about up here. And that is, suppose I have, just give me a moment here, A, right as a single log. I've got log base 3 of 10 minus log base 3 of 5. What does that equal? Well, remember, if I subtract, that means I'm dividing these numbers. So that equals log base 3 of 10 divided by 5. And that, of course, is log base 3 of 2. Okay, so what I did here is I didn't find the log of 2. I just simplified this very large expression. I'm going to do this again. And log base b of u plus log base b of v minus log base b of uw. Okay? Well, let's see what all this equals. First of all, I can combine these into log base b of uv. Okay, u times v minus log base b of uw. Okay? And I can combine these now because I'm subtracting. So I can say log base b of uv over uw. What does that equal? Log base b of v over w, because I canceled the u over u. You see? Isn't this fun? Okay, I can tell you're having a good time already. Let's try one more here. And this is the power property. So log base 5 of 25 to the 4th power. What does this equal? I want to simplify this thing here. And no, you guys that want to push your calculator button and push 25 to the 4th power, you're going to end up with a very, very large number. And then you try to find log base 5 of that. All right, let me show you a quick and easy way to fix this. That goes over there, remember? 4 times log base 5 of 25. Well, now it got real simple, didn't it? Because log base 5 of 25 is what? This is actually 2. So I have 4 times 2, which is 8. Now, again, you know, watch the button pushing on the calculator. You know, this is an easy, fast, simple way to do it, knowing your logarithms. And if you don't know your logarithms, I guarantee you're going to have some problems coming up. Now, there's a couple other things I got to show you here. And one of them is the inverse property. Okay? So if b is greater than 0 and b does not equal 1, then log base b of b to the x equals x. Remember, b to the x and log base b of something, these are reciprocals of one another, okay? They're inverses of inverse functions. So remember, if you take a composite function of inverse functions, you should end up with x. Anyway, trust me on this one, okay? B to the log base b of x equals x. So b to the log base b of something equals something. Log base b of b to the something equals something. So that's how that works. And let's see how you do a problem like that. If you have 3 to the log base 3 of 4, notice b to the log base b of x, 3 to the log base 3 of 4. What does that equal? Oh, wait. No, but wait, there's more. Okay, I'm going to add plus log base 5 of 25. Well, log base 3 of 3 to the 4th power is 4, because of this rule right here. If you got log of base b of x, you take b to that power, you've got an x. Okay, so 4. What's the log base 5 of oh, wait. What am I doing? Yeah, I can make that too, but okay, this says log base 5 of 5 to the 2th power, okay? So basically we have b and b here. So 5 and 5 here. So, but you already knew this was 2 anyway, so this is 2. So the answer is 6. So let's go back and let's go on and find another one of these. Log the base 2 of 32 minus 5 to the raised to the power log base 5 of 3. So what is this going to be equal to? Well, log to the base 2 of 32 is actually 2 to the 5th power, minus 5 to the log base 5, that's a 5 there, of 3. That's the same thing that you got right above there. And so that's going to be 3. You just pick this one right here. That's 3. And log the base 2 of 2 to the 5th is, of course, 5. So 5 minus 3 is equal to 2. So that's how that works. And there's one more property. And I might get this one done in 20 minutes. Hey, man. One more property that works that we're going to use, and that's the 1-to-1 property. And this might sound familiar because we just talked about a 1-to-1 property, didn't we? Don't answer that. I know we already did. So the answer is yes. So first of all, for exponents, this is just a review. This is what I told you before. If b to the x equals b to the y, then x equals y. Whoa, there's another one for logarithms. Some of you guys are going to be smart enough to figure this out, or you're going to look at it and say, well, of course. Logarithmic one-to-one property says if log to the base b of x equals log to the base b of y, then what? Of course, x equals y. And so let's try solving one that uses this property, okay? And this is the last color change of the day. All right, log base 3 of x squared plus 7x minus 5 equals log base 3 of 6x plus 1. Well, this is x and this is y in this thing right here, okay? Log base b, log base b. The bases are the same, so we can just make these two equal to each other. X squared plus 7x minus 5 equals 6x plus 1. Isn't that neat? And now we just subtract 6x from both sides and subtract 1 from both sides, and we get x squared plus x minus 6 equals 0. And of course now we can just use the 1-to-1 property. We can factor this. X plus 3, x minus 2 equals 0. X plus 3 equals 0. Subtract 3, x equals... I'm listening to you guys now saying, I thought we were done with quadratic equations. No, ladies and gentlemen, you are never done with quadratic equations. Not in algebra or anything you're going to take after algebra. So the answers are x equals 3 and x equals 2. And that's the good news is we're at the end of the lesson. Thank you. Bye-bye.